equations, and so we will try to solve separable differential equations. More complicated than examples given on the lecture. Okay, so task number 1. Let's solve the following differential equation. So let it be dy over dx equals y times y plus 2. Okay, welcome. This is a chalk.
Step number 1, variable separation.
All right. So we want to integrate, right? We want to integrate, and in order to integrate, we should represent this fraction as the difference of. So we should use partial fraction decomposition, right? Right, and then we can differentiate, right? So integrate. Sorry, integrate.
Which log do you like?
Log, right. So I see. So it is used in foreign textbooks, right? I see. Y plus 2. But I'm used to ln natural logarithm. But you can use this. Okay, so let it be. This plus c. All right. Okay, so this is the solution. This is an implicit function, right? Implicit function, and we may leave the solution in this form. But we may solve for y, and maybe let's do it. And what about particular solutions? So didn't we lose the solutions?
We lost for when
y
is 0.
Right. And -2. Right. These are two solutions. Y equals 0 and y equals -2. And then we will try to solve, right? Correct. Right. So to eliminate, so first, there are several steps. First, we eliminate the logarithmic function, right, by using the exponent, right? And next, we remove the absolute value by introducing a constant, by saying that a constant may take positive and negative values and 0. And so y equals 0 is included in this family for c equals 0. Right? Sometimes for so using some manipulations, some manipulations will lead to involving a particular solution into the series of one parameter series. Family of solution, right? And then how to solve for y. Okay, you may use this space. If we want to solve for y, so we will get a linear equation in y. Right? If we multiply, right? 2, right? Then expand. Use this space.
Okay.
So there is space. Then we may expand, right? Correct. And then y equals, so just divide by this, and we will get the answer. Right. Okay, y equals 0 is included in this family for c equals 0, but what about y equals -2? Is it included or not?
Y equals
-2. So it seems that it is not included. So we should write a comma, and so we should add this solution to the general answer. Just write y equals -2.
Oh, okay, yes.
So to obtain the general solution, and this is their final answer, this and this.
How did you know y equals -2 is not included?
Oh, it is easy to check. So if c, so just in this way, if c is not 0, then this function depends on x, but this doesn't. Right? So to check that this is not included. So if c is equal to 0, then y equals 0 is included, right? But if c is not 0, then this depends on x. Right?
Oh, okay.
Right?
Yes.
And so since this depends on x and this is not, this doesn't,
Okay, yes.
then it is not included in this family. But maybe if you are not sure, maybe. So it's better to write these particular solutions. If you are not sure if particular solutions are included or not, it's better to add them, to include them in the general solution. It is better than to lose them. Okay, so thank you.
Okay,
it's correct.
I'll solve the next one.
Oh, okay. Right. So the next one will be, so task number 2 will be x squared plus 4 times y prime equals 2xy. Do you want to solve? All right. Well,
so
okay, so you need not write the functions. We're not interested in these functions. So just separate variables. If you can see, so you have dy on the left, and then your goal is to gather all the variables y in the left. So you can see y here, so you should divide by y, right? And you should move dx to the right and x squared plus 4 to the right. Times dx. Correct. Right. Then you should, on this stage, you should check if so whether you lost particular solutions or not. Right.
Yes,
so you have divided by y, so a particular solution will be y equals 0. So I think it's not correct. So h of y equals this. So just I think we may do this. So y equals 0. So a particular solution, right? Or maybe right. Just remark this, and this will appear in the final answer. Now we will not care about this. Right? So we will solve this, we will discuss this equation, this one parameter family of solutions, and then in the final answer we will, so we should remind this, right? And write this answer. Then integrate. Right, correct. So this is a substitution. Yeah, it's correct.
Okay.
Right, absolute value of t plus c, correct. Okay, so this is already an answer, but if we are able to solve for y, then it's better to do this. Maybe you can do this step by step, because
yes,
they will ask how to obtain this answer. So e to this power, so you may use so e to this power equals e to this power, right? E raised to the power logarithm the logarithm of x squared plus 4 plus c times e to c, right? C1 multiplied by x squared plus 4, correct. Okay, and then
it's included, right?
Right, it is included, of course. If C1 is an arbitrary value which can take positive, negative values and 0, then y equals 0 is included here. So this is a final answer. Let's write the answer. Okay, and where is the answer? So, and this is also the final answer. Right. Correct. So maybe okay, right. Sit down, please. Next, I will solve the next one, and after this, you may continue solving problems. Thank you very much. You are very good in solving differential equations and in integration, in integrating. So task number 3. Okay, we will try to find the solutions of the following: minus x e to y. I think it's not difficult. Well, let's represent it in the form dy over dx equals minus x e to y. Then separate variables. Dy over e to y equals minus x dx. Since we divide by e to y, so e to y is always positive, so we will not lose solutions. Then integrate. Okay, so the integral of dy over e to y is equal to the integral of e to negative y dy. It is equal to negative e to y. So plus the constant. But it should be written on just one side of this equality, and so we will add constant to the second integral, to this integral. And so we will get the following: minus e to y equals a minus x squared half plus c. Next, what shall we do next? So change the sign. So if we want to solve for y, we will do the following. It will be x squared half minus c. So plus c, because c is an arbitrary constant. And then y equals the logarithm of x squared half plus c. Okay. If c is positive, then this function is defined for all possible x's. right? If c is negative, then this function is defined only on an interval where x squared half is greater than the absolute value of c. Okay, but this is a solution. Well, okay. Next, number 4. Okay, find a particular solution of the differential equation. A particular solution. So we have a differential equation given by this formula. So x should be positive because we take the logarithm. The logarithm should exist. Okay, provided that y of 1 equals -1. So this is an initial condition, right? This is the initial condition. So we will find the general solution of this differential equation, and then after this we will use this initial condition to find the constant of the value of the constant, and to find a particular solution. Which obeys this restriction, this initial condition. Okay, well, let's try to separate variables. It will be x times y plus 2 times dy over y, or over dx, equals ln x plus 1. Oh, okay, welcome.
One-person seminar.
All right. Follow next time you should come to the seminar. Try to find the room, please. So next time you will solve one by one. So Kathy, then follow, then Kathy, then follow, then again follow. Because it's not interesting. Only one person. Okay. Right.
Okay.
Right. All right. So then to integrate. Okay. And then x, we may not use the absolute value because x is positive in the original differential equation. Okay, so now we have the light. Maybe I will try to. So maybe close the window. So it's okay. It seems to me that the light is not good now, or not. Maybe right. Close the window and then. Let's try. Well, maybe it will be better. Right. So now we will not solve for y.
No. Okay.
Right. So, not solve for y, but we need to know just one solution.
Yes.
Satisfying
Y-
this
yes,
initial
particular
condition.
solution.
Right.
Y equals 1.
So we should substitute -1 for y and 1 for x, and then find the constant first, and then to write the particular solution.
Y minus 1.
So minus 1 for
Oh.
y and 1 for x. So okay, so this is x and
yes.
this is y, and so not a logarithm of -1, of
Yes.
course.
So
Okay, so we'll use this clause. Hold your hand. -1 squared, correct. Minus 2.
now what is ln of 1, 0?
Right.
So this is half minus 2, which is equal to minus
3/2. Correct.
3/2. So
C is equal to -3/2, right? And the final answer, it can be given in this form, of course, so you need not solve. Right, so let's write the word answer and so and this, so y squared half plus 2y, and so on. Correct. Thank you. Okay, well, next let's solve the following. Maybe I hope they are ready. This I will use this part. Number 5. Let's solve the following: y prime times quad 2x plus tan y equals 0. What shall we do? So let's, I'll try to solve dy over dx times quad 2x. Okay. Y equals 0. Then first we should move tan x to the right. Then separate variables. Dy over tan y equals, so it's not cos, it's cot. It is cot. Equals dx over quad 2x. Okay, so let's consider the case when tan y is equal to 0 or quad 2x equals 0. Okay. So let's consider them separately. Tan y equals 0 means that, so tan y equals 0, then y equals pi times n, where n is an integer number, right? Is it the solution? Is it a particular solution? So y equals pi times n. Of course, yes, if we substitute Okay, so if we substitute pi n for y in this formula, we will get 0 here, and dy will be equal to 0. And so this is a solution. And now let's consider the second case. What shall we do if quad 2x equals 0? So this is of course possible, right? This means that 2x equals, so quad x equals 0 if 2x equals pi half plus pi n, where n is an integer number. So this means that x is equal to pi fourth plus pi n half. But is it a solution of our differential equation? Is this a solution? What is your opinion? So maybe, so the question is, so it is important because sometimes we obtain a solution of the given differential equation in the implicit form, right? In the implicit form, like this. So it doesn't matter whether y is a function of x or x is a function of y, right? So maybe they have equal rights. X and y may have equal rights or not. Is it true or not? Should we consider these particular solutions as solutions or not? Well, in this case not, because we have the original equation is y prime times something. So dy can be equal to 0. So in this case, y equals pi n and dy equals 0. So y is a constant, is a function, right? But we divide by dx, and so dx cannot be equal to 0, right? So dx cannot be equal to 0. And so in this case, y prime, if x is a constant, then we can't find y prime. Yeah, y is not a function of x. Okay, had we given almost similar differential equation, had we given the equation in the form dy times quad 2x plus dx times tan y equals 0. Had we given this equation, we would say that these are particular solutions and these are particular solutions, because in this equation x and y have equal rights, and so if tan y equals 0, then dy equals 0, it is possible. So quad 2x equals 0 and dx equals 0 is also possible, right? So I want to emphasize that these two differential equations are different, right? And because they have different solutions. So this series of this family of solutions will not be included in the answer, because so these are not particular solutions. Okay, right. So let's continue. Now we have separated the variables, and now let's integrate. Okay, how to do this? Do you know how to integrate tan y or quad 2x? What about Misha? Monica is not here. Okay, Misha Zhukov, do you know how to integrate tan x? Or follow? So it seems to me that follow is able to integrate tan y, dy over tan y, but what about Misha? Hello. Aha, okay. Misha, right. Okay, can you integrate dy over tan y? Do you know how to do this? How to find the integral dy divided by tan y? Okay, what shall we do to find this integral?
Well, you can start by writing the definition of tangent.
This is
I'm solving for one of the trigonometric functions, I think. There is a way to prove that z is equal to something like proportional to like x squared minus 1 or square root of x squared minus 1, something like that.
No, so it is tan y, so not right. So not this. So first we should represent tan y is as the ratio of cos y and sin y, right? So it is equal to cos y dy divided by sin y. So this is the first step. And next,
then we can probably use the fact that sin squared plus cosine squared is 1.
okay, no, so it will not lead us to the final integration. So then substitution or change of variables. Okay, if we introduce a new variable u, which is equal to sin y, then du, what is du? So you should differentiate sin y. It will be cos y dy, right? And so this integral is equal to du over u. And now can we write the answer?
Yeah, we can. If we integrate this, it would be the logarithm of u.
Right. Plus the constant. Right, correct. Now it's correct. Now our goal is to integrate dx over cot 2x in the same way. Right. Likewise, we can represent cot 2x as the ratio of cos and sine, right? And it will be equal to sine 2x dx over cos 2x. Then we will use a substitution, u equals cos 2x. Then du is equal to minus 2 sine 2x dx. And it is equal to the integral, so minus 1/2. So minus 2 will go to the right, to the left, sorry, minus 1/2 du over u. And it is equal to minus 1/2 the log. Oh, so u is not good. So let it be v. I will make a back substitution, ln sine y plus c. And here we have ln v and v cos 2x plus c. Okay, and we have the following. So ln the absolute value of sine y equals minus 1/2 ln absolute value of cos 2x plus c. What shall we do next? If we want to solve for y, it is possible to solve or to simplify, or just to simplify this. So we can multiply by -2, both sides by -2 first. Or not negative. Let's or maybe only 2, maybe, right, only 2, and then to represent this as the logarithm of sine squared y equals ln of 1 over cos, right, cos 2x. Is it clear? So using the following property of the logarithmic function, so a log, let it be log b is equal to log b to the raised to the power a. Using this property, so we have -1 here, and it can be it can appear as a power of cos 2x, and if we multiply by 2, we can represent it in this form, right? Plus c is an arbitrary constant, then we can remove logarithmic function and write sine squared y equals next c times so c divided by cos 2x. Okay. So sine y is equal to root. So, or maybe it can be represented as c over root cos 2x. Or not. So it can be, it may be negative, of course. Just a moment. Okay, well, I will not do this. Okay, let it be c over root of the absolute value of cos 2x. Okay, I will use absolute value function. Okay. So, well, this is the solution. Or next we can take arcsine function, and we should include the points y equals pi times n, where n is an integer. So this is the answer. Well, I think it's time to the break, right? For the break. Let it be the break. And we will discuss homogeneous differential equations. Do you know what a homogeneous function is? A homogeneous function depending on two variables. What does it mean that the function is homogeneous of order n, for example? Homogeneous of... okay, so this is for a polynomial, right? So, for example, if we have a polynomial, maybe x squared plus 3xy plus y squared, right? This function is a polynomial of degree 2, right? Okay, so right, of degree 2. But what about this function? For example, x cubed minus x plus y. Is it a homogeneous function or not? No, so not a homogeneous, right? Well, so how to check this? And another question is, there are some functions, not necessarily polynomial functions, that are homogeneous. So the test for homogeneity is the following. So we should substitute tx and ty for x and y. And if the following condition is satisfied, so tx times ty, if it is equal to t to n times f of xy, then this function is homogeneous of order or of degree n. Okay, the examples of homogeneous functions that are not polynomials. For example, this is just an example. Let it be so tan of 1 plus y over x. If we substitute tx and ty for x and y, we will get the following. It will be equal to tan 1 plus ty over tx. What is it? So we can factor out t, right? We can cancel common factor t, and we will get the following: 1 plus y over x. We get the same function. So this function is homogeneous of degree 0, right? Okay, so t is raised to the power 0. Okay, what is homogeneous differential equation? Okay, if it can be represented in the form y prime equals f of xy, where f of xy is a homogeneous function of degree 0. So where then this differential equation is called a homogeneous differential equation. Then this equation is called a homogeneous differential equation. Or in terms of differentials, if a differential equation is written in the form, for example, p of xy dx plus q of xy dy equals 0. So sometimes we can see that differential equations given in the form of differentials, right, in this form, then we require that p and q be homogeneous functions of the same degree. Of the same degree. Okay. In this case, the method of solving homogeneous equations is to make a substitution. Y equals u times x. And then after this, we will rewrite our original differential equations in terms of x and u. And this substitution will lead us to separation of variables. So after this substitution, the new differential equation will be separable differential equation. So now I will show you the example. Let's move to that part of. Okay, so the next, I think it's not. It's number 6, I think, right? Task number 6. Let's solve the following differential equation: 2x plus y dx minus x dy equals 0. Is it a separable differential equation or not? No, because if we can't, so this is the sum of 2x and y. It can't be represented as the product. And so we can't solve this equation using the preceding technique. But it can be reduced to a separable differential equation by some substitution. Let's check whether this differential equation is homogeneous or not. So we have two functions. So p of xy is 2x plus y, and q of xy is negative x. So these two functions are both homogeneous of the same degree. Which degree? Right. They are homogeneous of degree 1. Okay, so let's try the following substitution. Y equals u times x. So u is a new function depending on x. So y of x is equal to u of x times x. Next, I want to substitute this function into this, this new function u into our differential equation. What is dy then? What is dy? Right. Right. So we should differentiate this, right? And it will be equal to so x du. Okay, plus u dx. Well, and now we will substitute this into our original equation, and we will get 2x plus ux dx minus x times x du plus u dx equals 0. Then it is the same as, we can rewrite it, we can expand and rewrite it in this form, minus x squared du minus xu dx equals 0. Then we can cancel out these terms, and we get the following equation: 2x dx equals x squared du, where u is a function of x, and we can see that the variables can be separated, right? So if we divide, so we can separate the variables. Du is equal to now it will be 2 over x dx, and we should consider x equals 0 as a particular solution. So x equals 0, so will it be a particular solution? If x equals 0, this will be this will give us 0 in the second term, and dx equals 0, right? So this will be a particular solution. This will be included in our set of solutions, but du is equal to 2 over x dx now, and we will continue a solution. Okay, let's substitute it. So let's integrate. So du equals the integral of 2 dx over x. Then u equals 2 ln absolute value of x plus c. This is u. And what is y? Y is equal to u times x, so it is equal to 2 ln absolute value of x plus c times x. Okay, so this is the answer. So answer will be y equals x times 2 ln absolute value of x plus c, and x equals 0 is a particular solution. Okay. Okay, Kathy, do you want to solve the next? Will be task number 7, so let's solve this one. Xy prime equals y times ln x over y. Well,
Okay.
We can rewrite, so one way is to rewrite it in this form, f of x, y, and check whether f is a homogeneous function of degree 0.
I can make substitution and yes.
Right, and then we should make a substitution y equals u times x, and this will lead to a separable differential equation. Just differentiate the product. You may differentiate the product if you want. Just
Oh, okay.
maybe it's better now. Yes. So if you differentiate the product, so y prime, maybe we will use this. So y prime equals, and then the derivative of the product. Right, and plus u times, right, that's all. The derivative of x is 1, so it's correct.
So
u
and x by y, so x divided by
ux. Correct.
And now
right, and rewrite this equation in the right, u prime x, right, plus u equals that's correct. Then try to separate variables.
okay.
To separate variables, we should move a u to the right hand side first, and then divide and multiply.
So it is
minus
u,
right,
minus
then u, right, correct,
and so I have
right, right, correct.
and particular solution should be checked.
Check the particular solution. So x equals 0 can't be a solution because we divide by the x, right? But u equals 0 and 1 plus ln u equals 0 should be checked, of course. So u equals 0 and 1 plus ln u equals 0. So if u equals 0, then y equals 0, a particular solution. It can't be, so we can't divide by y, of course.
Yeah.
So no, it's not a particular solution, but what about this? So ln u equals minus 1, and so u is equal to 1 over e, right, 1 by e. And then y will be equal to x by e. Is this a particular solution? So let's substitute it into the original equation. So let's check that x times what is y prime. Y prime is 1 over e equals it will be x over e times the logarithm of x over, so it is 1, right? So it's true. Right, so this is a particular solution, right? And continue to solve this.
Okay.
So integrate.
Okay, so And
right, where t is correct.
so this is double nonce.
Let's see, right?
Now,
Then substitute 1 plus ln u for t.
or should I remove ln first?
Remove right. You may do this. Remove first. Divided by x, right? Right.
Now,
Then maybe we'll just a moment. I will remove maybe this. So we remember that. I will remove this part, so it is not necessary. Use this space.
now t is 1 plus ln is equal to c by x.
Right.
To find out u.
Not y but u.
Oh yes.
It's u. And then y. This is u, and then y is equal to the product u times x.
Y is equal to ux, which is equal to
Thank you. Okay, and the answer will include these two functions. So I will rewrite y equals x over e. So comma y equals x over e. So this is their answer. Thank you. Okay. Then task number 8. We will solve the following equation. xy plus y squared times y prime equals y squared. Okay. Let's check that this equation is homogeneous. So we have this function and this function, and they are both homogeneous of degree 2, right? So this is a homogeneous equation, and we make the substitution u times x. We need y prime, so y prime will be equal to u prime times x plus u. So the derivative, the product rule, right? The product rule. And after this, I will substitute u times x for y in this equation. So it is equal to x times ux plus u squared x squared times u prime x plus u equals u squared x squared. Okay, so is it clear? So just differentiate. So make a substitution, differentiate, and substitute ux for y. Next, we should expand, and we will get the following. So just multiply. It will be the coefficient of u prime will be x cubed u times u prime, so the product of the first terms, next first by the second, so plus x squared u squared plus u squared x cubed u prime and plus u cubed x squared equals u squared x squared. Next, we should eliminate these parts. Okay, and what shall we? What do we have next? So, u prime is a common factor, and we will factor out it. So u prime is multiplied by x cubed, so times x cubed times u plus u squared. So u prime and x cubed are common factors of these two terms, and it is equal to minus u cubed x squared. Next we divide by, so next we separate variables, so du over dx is equal to, let it be, x cubed u plus u squared equals minus u cubed x squared. Then we will gather u on the left and x on the right. So collect, sorry. We should collect terms with u on the left. So du is multiplied by u plus u squared and divided by u cubed, and it is equal to minus x squared dx divided by x cubed. Next we will simplify, and we will get 1 plus u. So we divide, so u is a common factor in the numerator and denominator, and we will divide out u, and we will get 1 plus u du over u squared equals minus dx over x. Okay, have we lost particular solutions or not? So we have divided by what? By u. And and by x. So x cannot be equal to, x equals 0 is not a solution, because then dx equals 0, and this will not match this, fit this. And now we should consider a particular solution of the form u equals 0. So since we have divided by u, is it a particular solution? So if u equals 0, then y equals 0 also, because it is the product of u and x. If so y equals 0, of course satisfies this differential equation. So it is a particular solution. And then let's continue solving this. If we integrate both parts, we will get, so the first integral will be du over u squared, next plus du over u equals minus dx over x. So this is minus 1 over u plus ln u equals minus ln, let it be absolute value of x plus the constant. Okay, what shall we do next? I want to know, so we were asked about the functions y, so to find the relationship between x and y, but our answer includes u. What shall we do? Next. Misha Zhukov is the last student with us, right?
You need to substitute u in terms of x and y?
Right, so we will substitute this, right? So from this substitution we can see that u is y divided by x, y over x. And so we will substitute this into our relationship, right? And we will get the answer in terms of y and x. We will get an implicit function, an implicit solution of our differential equation. Then we get the following: minus 1 over, so u is y divided by x, so it is not 1, but it is x over y plus ln y over x equals minus ln x plus c, and a particular solution y equals 0. So this is the answer. Okay, we have time to solve the last problem, the last task. Let's do it. Okay, task number 9. Do you want to solve? No problem.
There should be some mistake.
Okay, where?
Either here or there.
Okay.
I made or
Let's check. Right, so differentiate y in this form. Next, substitute y prime and expand. X cubed u prime plus x squared u squared plus I think it's this. So next, cancel out factors x cubed u. Let's check. So in my opinion, it's okay. So I think it's correct. So what is your equation? Is it like this or not?
But instead of y cube, I get y squared.
Sorry, what you squared?
I think I get a y squared here.
Y squared, but it goes from here. So u squared x squared times u cubed goes from u cubed comes from this product. Look here, u squared x squared times u cubed.
Okay.
And then it moves to the right, and next division by u cubed. So is this the only difference, or so u cubed or
I solved in a little different way, but
right. And what about your equation? But if you have integrated, so before the integration, what is the equation before the integration?
This one.
This one. So and then so we should separate variables and then integrate. To integrate, you need, maybe if you rewrite this, you will get the same, because next if we eliminate u, so we can cancel out like factors from numerator and denominator, and we will get 1 plus u divided by u squared.
Oh, let me
I
check.
think it seems
u times
similar.
1 minus u.
U squared divided, right?
Oh, yes.
And then after this, if we divide, right, I think it's the same.
Yes.
Okay, so
I cancelled.
right. It's you may do it. So okay. Correct. Okay, the last task will be, so it will be x cubed plus xy squared times y prime equals y cubed. Okay, so both functions are homogeneous of degree 3, and so this differential equation is homogeneous. Make a substitution. Then y prime equals u prime x plus u, and then we have the following: x cubed plus x cubed u squared times u prime x plus u equals u cubed x cubed. Maybe we will divide by x cubed, both parts by x cubed. I think this will simplify our computations. Then we will get 1 plus u squared times u prime x plus u equals u cubed. Next, expand u prime x plus u squared u prime x plus u cubed equals u cubed. Then cancel out like terms. And next I will move here. Then we have the following: u prime is multiplied by x plus xu squared equals negative u. I think it's correct. Then du over dx times 1 plus u squared equals minus u. Then we separate variables and we get 1 plus u squared over u du equals minus dx over x, and then integrate both parts. So we have the integral of du over u plus u du equals minus ln absolute value of x, then ln u plus u squared half equals minus ln x plus c. And after this we may substitute y over x for u, and we will get the final answer. So it will be y over x plus y squared over 2x squared equals minus ln x plus c. Okay, so if we join these two logarithms, we will get the following: the logarithm of y over x plus ln the absolute value of x equals logarithm plus y squared to x squared equals c, and then it is equal to logarithm of y I think it's better. Or maybe y equals c times e to the power minus y squared over 2x squared. But this is an implicit function, not explicit, because we can see y here, right, in the power of the exponent. Okay, so that's all. We may finish here. So this was the last task. Okay, and now bye, see you next time.